So we already discussed numerical expression. Just to reiterate again, it's a symbol or group of symbols used to represent a number. It should be reviewed. These are the same expressions as you can see here. Both of them are identical, are 18. Okay. That's what I think, guys. I apologize, but sometimes it's a little hard. The equation. You all know what the equation is? Let me give you our definition besides the one that's on the board. What's the equation, Steve? An expression with equals. Very good. Again, an equation is a sentence form of putting an equal sign between the two expressions. We've all seen this before. Something, for example, maybe as simple as 2x plus 4 equals 8. Okay, there's an equation, and we know we can solve equations as well. Again, should be reviewed. You don't have to write down the definition of the equation if you know it. I'm not going to test you on the definition of the equation. You just have to know what it is. Next, equality symbols. Okay, inequality symbols. This still indicates two expressions are not equal to one another. Okay, with the exception of these two, because those could be equal, right? Less than or equal to, greater than or equal to. Hence the name or equal to. So traditionally we have not equal to, greater than, less than, greater than or equal to, less than or equal to. And I assume you've all seen these before. Is this new to anybody? And if it is, please tell me on this. Okay? Next, inequality. Inequality is just like equations, but what's in the middle instead of an equal sign? Inequalities. That's all. Same thing we did before. 3x plus 1 now is less than 4. So now we're going to solve and we're going to get a set of answers for our solution set. Then we're going to solve, we're going to have something x is less than something. Okay? Again, it's the same thing as an equation with an inequality sign. I don't go quick today. Again, it's review. Let's look at an example here. And this is a very basic one, but you know what? This is a simple multiple choice for the SAT. Your choices will be like A, B, C, D. It'll be equal to, less than, greater than, or like none of the above. It's choice. You know, choose which one makes sense. So how do I do this problem? What do I do on the left side? Just go through. Okay, left side. What do I got? 27 over 3? 9 plus 4? 4 squared? Then the answer. Okay. 13 is greater than 11, right? 3 greater than 7. Simple enough? Again, should be reviewed. Any questions? So, basic operations. This stuff I'm really going to flag. When you see the word sum, what do? You add, right? Add what are those called? They're called terms. Things you add together. When you see difference, you subtract the terms. When you see product, you multiply the factors. Quotient, you just simply divide. That's definitely review already. Power, you all know what power is? Power is simply the idea that you have a multiple factor written after one another, but it's the same factor. 2, 2, 2, 2 is 2 to the 4. The base of the power, is highlighted in red here, this 5 here, is the base. It represents whatever factor is repeated itself. So since the 2 repeated itself 4 times, the 2 is the base. And the next one, exponent. The exponent is the number of times it repeats itself. So here the exponent is 4, here the exponent is 2, here the exponent is simply 3. Remember, this only occurs if the exponent is positive. Remember negative exponents, how they work? Anybody remember what a negative exponent does for us? Again? Get smaller good. So for example, if I had like 2 to the negative 3, what is that really? How do I write that? Remember how to write that? With positive exponents only? 1 over 2 to the third. Well done, a very good memory. 1 over 2 to the third. A negative exponent simply means move it, make it positive. If you had a negative exponent at the bottom, if this were 2 to the negative third at the bottom, you would move back up to the top, make it positive. Okay, just always move the spot, make it positive. Substitution principle, very basic. If something is equal to it, you can replace it. For example, we're looking at the next one. I'll explain that. If we have, we're on order of operations, the only trait that a lot of students forget, these are grouped. Remember that? Multiplication and division are grouped. So you have to do it in the order they appear. So start with your brackets here. Parentheses. What's 5 minus 2? 3. So I'm going to have 3 to the third. What's 3 to the third next? What is it? 27. So let's replace that with 27. Well, that's substitution method, isn't it? Think about it, right? It's the same thing. You're just substituting a value. Next, I've got divided by 9. So this is going to be 3. How do I want to do that next? It said multiplication here. How do I want to do division next? Because they're in the same group, and which one came first? Addition. Again, simplifying from left to right, from left to right. So I've got this whole thing is now 3, right? So but I have still minus 3. I can't do that again, right? Because I still have time symbol. So I see the time symbol. I got to take the operation first. 3 by 6, 18. So substitute in, and now 3 minus 18, negative 15. Negative 15 and 12 is negative 3. Careful. Positive 12. Okay. Good. You good? Okay. Okay. Very basic problem. You've all seen this before. Given some variables, figure out what the expression actually value expression is. Okay? So we don't know what a variable is. I don't really need to define a variable. So if we're given these three quantities, what do? We set it through it. Just plug them in. Very good. Then we call that substitution. I use the word plug in. Plug in. This problem, if I ever say it's plug and shove, have you heard that term before? Plug and shove? It means it's an easy problem. You're just plugging something in and go into the motion. This should not be difficult at all. So we have 7 plus 3 over 6 plus 7 plus 6 over 3. 7 and 3 is 10. So here I'm going to get 10 over 6. Plus here we're going to get 13 over 3. Now here's a question for you. When I add fractions, what do I usually do? So what would you do to start this one? Yeah, I agree, and that's what I did first too. I would make this a 6, and make this a 26, right? So you double both. But you can also just have this. Most people forget that. You just make this 5/3. Isn't that what it is, really? Isn't that 5/3? So it makes it a little easier. You can reduce easier. So you're going to get 18 over 3. Michael, have you done it the other way? You're absolutely right. We've got 36 over 6. What are they both equal to? 6. So it doesn't really matter. But a lot of people forget that you can simplify first. And they always make the common denominator. Just makes things easier for you. If you simplify this first, the problem might be less. But again, answer doesn't matter. Alright. Next. This is a problem that I think is very interesting in your book, and it talks about expressions. Use 5 twos to write an expression whose value is 7. Whose value is 7. It's going to give you maybe a step here, an idea of what we can do. We need to use the number 2 5 times and get the value to be 7. Just 2. So the only number you can use is the number 2. And you can use it, though, 5 times. And you have to use it 5 times. So it's S. Got it? It's up to you to decide. Any operation you like. You decide. You can use square root if you like to. You can use plus, subtract, multiply, divide. You learn other things later on, which we're going to use in our operations. You can use like, you can square it, so you can 2 to the second power. Right? Because you can 2 twos there. Anybody have an idea? Yeah, I don't know what I'm looking for. I'm thinking that's try it out. Try different operations, see it. You can't just sit there and think about it sometimes. Actually try different examples, and you'll see, oh, that's a little bit below 7. I gotta make it bigger somehow. Or it's too large a number, I gotta make it smaller. What you're being tested on right now is called number sense. Sense of numbers. You have to be able to do this. It's a little bit tough. And it's a hard thing to teach for me too. Because I just sometimes you see things. It's difficult to explain. I didn't know that works. So I try stuff out. It becomes easier. Well, you can only use the number 2s. So 2 squared is 4, 2 squared is 4. This is 2 2s, this is 2 2s, so you have one more 2 to use. Can you do that? You can just use these 2 and then you go 1 7 like that. You can only use 5 2s again. You can use the next one. So for example, you can't use 2 to the 4 because this is not a 2. You can only use 2 squared because this would be using 2 different 2s here. I'm telling you, you can use 5 2s to come up with number 7. It's not easy, and it's not easy, especially when you see it the first time ever. When you do more of these in practice, more it gets not easy. You gotta try, keep trying, guys. Use other operations. Try division, try addition, try subtraction, multiplication. And by the way, in this case, if you will notice, it's no different from doing this and this, right? So really you don't need exponents in this problem because of this. Here's another one. Try to figure out this one. We both got the same number. And that's fine. That's what I got also. But I just saw another way actually. Just now. Just now. Say again? Let me just switch the order. I'm thinking of a different. Let me check to make sure it works right. So both ways have been discovered. There might be others, but the first way you guys got, that's what I thought. The one you just did now is the second. So you got both things on. There might be a third way to do it. Alright, that's the same as. Again, name, sorry? Nicholas. Same as. Try on the other one. Sorry. I can put up one of the two methods so people can get an idea of one way and maybe they can try and find the other. The first way I saw an answer was Manny, right? Manny knew the first one. So the first way Manny wrote was 2 plus 2 plus 2 plus 2 over 2. Right? We get 6 here. 6 plus 1 gives you 7. That's using all 5 2's. And there is another way though that Nicholas had. What's it? John? Nicholas and John. Okay. Sorry. Good try, though. You got it. It's fun. Keep going back. So you can erase it, right? I haven't seen another way in my head because I'm trying to think of some other possibilities. So there's definitely a second way that does it. Are you reversing the order? That's absolutely different. Absolutely. Summer. Yeah. Believe it or not, you're absolutely right. Summer got this. Because this is really 4, right? And this is 4. Summer, you could have also, instead of writing like this, you could have written 2 times 2 plus 2 plus 2 over 2 also. Absolutely. Those are the variations of that. They are different. Yep, that's what Nicholas and John. Very good. Yep. Awesome. That's one of the methods. The other one that the 3 gentlemen got so far is very different from the rest. Or at least not that Nick, you're the first one. What do you got?
2 times 2 times 2 minus 2 times 2.
Just got it? 2 by 2 by 2 gives us what? 8. 8 minus 1 is 7. Okay? So there's not just one answer to these kind of problems. Now, I'll tell you right now, I'll definitely give you a problem like this on your test. Okay? Just give you a heads up. And your homework, you're going to have some practice problems to see these. So if you, for example, I'm only going to give you the odd ones so you can check the answer to that. But if you need more practice, look at the even ones also with these kinds of problems. Okay? Alright, that's it for section 1-2. We've got about 7 minutes left. We can hold off there, I think. And do you want to do something else real quick? There's your homework for tonight. So, remember yesterday I talked about written exercises? Okay, written exercises, that's what you're always going to be doing. What I also gave you tonight was a section from 1-1. So go back to 1-1. What's MR stand for in your book? Anybody know what that was? What is it? Yeah, it's a section called mixed review. Okay? So this is your homework based on what we just did, section 1-2. Again, very basic stuff. You're going to do the multiples of 3. We all clear what that means? You're going to be doing 9, 12, 15, 18, 21, etc. all the way to 51. Okay? Multiples of 3 for your homework. You're going to see me do this a lot. Instead of being odd or even, it'll be multiples of 3, sometimes multiples of 4. Okay? Depending on how much homework there is. Then go back to section 1-1 and take a look at the first, or look at numbers 1 through 11 and do the odd problems in the mixed review section. I'll tell you now, every time you get a homework, I'm going to try to go back to another section and give you additional homework. Just be keeping that knowledge cumulative. So when we're on chapter 7, section 4, I might also give you chapter 5, section 1, and a few problems out of there. So we're not just saying, well, we learned this and now we're done with it. Okay, we're clear on that? We need to keep that knowledge if you're going to fall out of your head. You have 5 minutes. You can start section 1.3, I think I'm going to. Just because section 1.3 is similar to this section, it's very straightforward, and it should be a lot of review. Any questions though about anything so far? I don't actually, it's not my head, I'm sorry. I use section numbers because it's easier. I don't know. Is it going to be a problem? No. Okay. Yeah. I mean, look at your book along the bottom, I said, let's start writing pages on section numbers. Okay. Let's take a look at the next section, which is section 1.3. We'll begin now, and then we'll pick up with this tomorrow. I have you guys tomorrow, right? When's your day off for me? What day? Anybody know the day of the week is your day off from this class? Okay. So we have pretty much the entire week, and then you guys have off on Monday for this class. So what's going to happen is this. You're always going to be a day ahead of your class. Because their second day is their day off. So once day 2 comes around, it's always going to be staggered by 1 day. Just keep that in mind in case you work with other students on homework, you're not just doing the same homework in the other section. Okay? Alright. You've seen these before. I hope you'd like to review. If not, we'll go through them. But just to reiterate, okay, reflexive. Reflexive means the same thing on both sides. Literally the same thing. Whereas symmetric means 2 different entities that have the same value. How do you remember symmetric, by the way? How do you remember symmetric? This half of my body is called my what side of my body? This is my what? Right side. This is my... Traditionally, I know we're non-symmetric as human beings, but we should be symmetric, right? So your left side is equal to your right side. They're 2 different things, but they're equal. That's symmetric. Whereas reflexive, you literally see the same thing in the mirror. You see a reflection. It's not like 2 different parts. Again, when you split your body in half, it should be symmetric. There are 2 different entities that should be the same. But when you look in the mirror, you're literally seeing the same thing. A equals A. You're seeing your face. That's your reflexive. In the mirror, here, halfway through your body. Transitive. I put AKA, changeable. AKA means also known as, the other abbreviation you use a lot, also known as. What's a changeable? What does it really mean? So we can give me an example of a changeable, where it might come into play in real life. Very good. Logical reason. Give me an example. Absolutely. Come on, give me an example of real life. Real life. How about it? Acceleration equals gravity. Gravity equals. The theory's right. Not necessarily though. Physics, you don't say that, but I get what you're saying. Good. You're saying acceleration equals gravity, and how about this? Gravity equals 9.81 meters per second squared. That's the value. So you can use that. How about this? Manny, stand up for a second. Try to find 3 people with the same height. Erickson, how tall are you? About height of man? No taller? About the same? A little bit taller. Michael? Alright, let's say hypothetically. Well, this is pretty good. Erickson and Michael are pretty much they're pretty much the same height, right? Take a look at them. Approximately. So if they're the same height, and let's say Erickson and Manny are the same height, what can you say about Manny and Mike? We're also the same height, right? That's what the transitive property is. A lot of people confuse what it actually is. If these 2 things are the same, and these 2 things are the same, then the other 2 things are also the same. Okay? There's also the same idea where you can use transitive property but for inequalities. If I'm a short person. So you know what I'm doing. If I'm shorter than, let's say, you know, who are the teachers here? Who's your science teacher? Who is it? Miss Myers. I think she might be taller than here. Alright. She's shorter than you? Alright, let's say she is taller. If Mr. Howell is shorter than Miss Myers, and Miss Myers is shorter than Mr. Donson, then clearly I am shorter than Mr. Donson, right? It's a chain. You're applying a chain. Mr. Donson gave a speech at the mass. He did a really good speech. I just want to know what I thought was really good. What's that? I felt and we all said the same thing. We feel like the speech made you fun in the beginning, you know? Anyway, have an awesome day, guys. We'll pick up tomorrow with this. Again, your homework tonight, nothing on section 1-3. Okay, I'll post the video and notes from 1-2 and 1-3 so you can take a look if you need.